Welcome to The Explainer. Today, we are diving into one of the most influential AI papers ever written. This is the 2020 study that introduced the world to GPT-3, and, more importantly, a completely new way of thinking about how machines can learn. So let's start with a really basic question that kind of sets the stage for everything. How does an AI learn a new skill? Before this paper came along, if you wanted an AI to learn, say, how to translate legal documents, you had to approach it in a way that's totally different from how you teach a person.
Just think about it, right? You can teach your friend a new card game with just a couple of quick hands. But for an AI, man, it was a whole different story. Learning any new task was this massive undertaking. It needed a custom-built dataset with thousands, sometimes tens of thousands of examples for every single new thing you wanted it to do. It was a huge, huge bottleneck.
Now, this old method had a name, finetuning. And don't get me wrong, it was powerful, for sure. But it was also incredibly rigid and super expensive. Let's take a look at how it actually worked. It was always this two-step dance. First, you'd take a huge model and give it a general education by letting it read like a giant chunk of the internet. That's called pre-training. But then, and this is the key part, for every single new job, whether it was summarizing emails or answering questions about medicine, you had to go back and retrain it. You had to actually update its core programming using a brand new specialized dataset, a completely separate training process for every single task.
So the researchers behind this paper came along and asked a really revolutionary question. What if a model could learn a new skill on the fly? Just from the conversation itself, without having to go through that whole retraining process at all.
And this question led them to a really brilliant insight, a method they called in-context learning. The idea is, instead of fundamentally changing the model's brain through fine-tuning, you just show it what you want right there in the prompt. You give it instructions and a few examples as part of your request. And it turns out this works in a few different ways. Okay, first up, you've got zero shot. This is like the ultimate test of its understanding. You just tell the model what to do, but you give it zero examples to work with. You just say, translate English to French, give it the word cheese, and just hope it knows what you mean.
Then we can level up to one shot. Now this is getting a lot closer to how we actually teach other people. You give it the instruction, but you also provide one clear demonstration. So you'd say, translate English to French, sea otter equals loutre de mer. Then you ask, okay, now what about cheese?
And finally, we get to the star of the show, few-shot learning. This is where you give the model a handful of examples, maybe 10, maybe 50, all packed right into the prompt. This lets the model see the pattern you want it to follow without changing a single one of its internal connections. It's learning on the fly. So you might be wondering, why did this suddenly start working so well? I mean, people had tried this kind of thing before, but the results were always kind of meh. What was different this time?
The answer, in a word, was scale. Just staggering, unprecedented scale. The model they built, GPT-3, had 175 billion parameters. You can think of parameters as kind of like the synapses in the model's brain. And this was 10 times larger than any other model of its kind that had come before.
Now, this is where it gets really, really cool. This chart shows exactly why that scale mattered so much. See the smaller models in green and orange? Their accuracy barely moves, even when you give them more examples. They just don't get it. But now, look at that blue line for the massive GPT-3 model. Whoa! Its ability to learn from examples, that in-context learning curve, is incredibly steep. It gets so much better, so much faster with just a few examples.
And this wasn't just a one-off. They tested this across dozens of different tasks, and the story was always the same. As the models get bigger, their ability to learn in this few-shot way, that's the orange line here, it doesn't just go up, it accelerates. Scale wasn't just making the model a little bit better. It was unlocking an entirely new capability that just wasn't there before.
So the really crucial point here is that with this new key, this combination of in-context learning powered by massive scale, GPT-3 just blew the doors open on a whole new set of AI capabilities.
For starters, it could answer really tough trivia questions. And get this, it did it in a closed book setting. That means it wasn't searching the web. It was pulling facts directly from the knowledge stored deep inside its own parameters. And, as you can see, its few-shot performance was so good, it even beat the previous best model, which was one of those old-school fine-tuned models.
It also showed this incredible ability to reason on the fly. It could solve those tricky SAT analogy problems, the ones that require you to spot abstract relationships between words. And again, look at the trend. It's crystal clear. The bigger the model, the better it got at this kind of abstract thinking.
And then there was this, perhaps the thing that blew everyone's minds the most. It could write. It could write so well, in fact, that when they asked it to generate news articles, actual human judges had a really hard time telling the difference between its articles and ones written by a person.
But hey, it wasn't perfect, and to their credit, the paper was really honest about its limitations. On tasks that needed really deep logical inference or, say, comparing two different passages of text, like on this really tough ANI-Lie dataset, even the biggest GPT-3 model struggled. It was basically just guessing, performing not much better than random chance.
So the big takeaway here isn't just that GPT-3 was this incredibly powerful new model. It's that this paper revealed a powerful new method for building and interacting with AI. A method where you could get models to adapt to new things super fast without all that costly and time-consuming retraining. And that leaves us with a really provocative thought to end on. The jump from about 17 billion to 175 billion parameters unlocked this amazing, almost magical skill of in-context learning. So what completely new, emergent abilities are just waiting to be discovered with the next tenfold leap in scale? What happens when we get to trillions of parameters? We'll have to wait and see.